anything in the news we want to talk about before we get started? We just want to get started. We're not looking to get out early or anything. It's not like there's a party bus waiting for us, is there? That I don't know about? Okay. Are we all 21? We all can drink?
No.
Good, don't drink. All right, so now, everyone's signed in. Hand it back, all of them except for a few here. I'll hand them back while we're doing the in-class assignment that we're going to do today. I'll finish handing these back. Let's start with, you look at week 2. Number one thing you should be looking at is right up there at the instructions. So let me open up the instructions, because the instructions guide you through the week. They let you know exactly what's due on Tuesday of the following week. There's 3 parts of the assignment this week: number line, written assignment, Excel assignment. They're all due Tuesday of next week, which is September 12th, before class starts. Here are the materials for the week that when you're getting ready for the first quiz, which is only like in 2 weeks from today. No, 2 weeks from last Tuesday. So we're only a week and a half from the first quiz, the first test. It's usually a shorter one of all the quizzes. It's worth less points than all the other quizzes. And so don't expect you're gonna have the whole hour to do it. We'll start like at maybe 5 after 11 after we talk a little bit. And then you'll maybe only have like 35 minutes to complete it. So it's being prepared, is going back to the instructions from the weeks that you know will be on the quiz, and figuring out which PowerPoint slides are the most important, which answers that were posted from assignments that are going to be the ones you probably want to have ready to go to look at while you're taking the quiz. And if you're going to have open book, know the pages from these instructions. Those are the pages that have the formulas that you're going to want to use. And don't forget, last Tuesday I talked about how to use the book for practice problems, because the even answers are in the back. And I wrote these problems just like the problems from the book. So they're very similar. Go ahead.
For the quizzes, we don't always need the textbook, right? We can just
Say
use
that
the
again, we don't
slides.
always what?
We don't always need the textbook for the slide, for the quiz, right?
You can use it, but you don't have to, no. You can, it's
Just
open
use the
book, so
slides.
why wouldn't you use them?
You could just use the slides.
You can just use the slides, or you can use both slides and textbook, but don't be wrong, there's not everything's on the slides that's gonna be covered. I mean, there's stuff in the book. Multiple choice questions are coming out of anywhere. It's the problems you know are gonna come from, oh, he lectured about this, so this is a, let's say there's 8 problems on the first quiz, probably 5 are problems like the homework. And I don't stray into areas that I didn't lecture on when it comes to the problems. So the majority of the quiz is directly related to the problems we're doing on our homework that I'm showing you up on the board and everything. It's the multiple choice questions you gotta worry about. Those are the ones you might wanna book for, and you definitely are gonna use the PowerPoint for, but So if you're asking, can I get away without buying a book? Yeah, I think you could. I swear, was it this class, the other class? Somebody posted a link somewhere for everybody to find a illegal book online. Didn't anybody see that? Or am I the only one who saw? Yeah, you shake your head yes. So it's there, why haven't you downloaded that?
I didn't see it.
Oh, what, don't you have it? Somebody be his friend, will you? Somebody be his friend and help him out. He needs help, he needs to find that. Look how much money, now, if it's free, would you use the book?
Yeah.
Yeah, I would too. I mean, why not? Any questions about the instructions? Let's talk about what's due. Let me see, I want to think about how I want to talk about what's due. Yeah, let's talk about it. Let's go with the number line first. We're going with the number line. Is this it right here? Yeah. Okay, here's week 2's number line. It says, draw a number line with a bell curve drawn above it. Show work calculating and placing the usual 7 numbers under the number line, meaning 3 to the left, 3 to the right, and the mean is going to be 55.6, standard deviation 7.5. I want everyone to visualize that bell curve. Matter of fact, I have a picture of a bell curve. I don't think I use those numbers though. These are different numbers, but look at, here's the number line, -1, -2, -3, +1, +2, +3. Then you are now to put underneath the word mean, whatever the mean is in the homework problem, and then you add that standard deviation 3 times, put those numbers right underneath, subtract the standard deviation 3 times. Here's the difference now. You are to try to do your best to draw a bell over your number line. Look at where I blew it. This should be angled down much closer to the line right there. Look, I even tried to correct it. I need a new picture. That's the bottom line on this one. Look at over here. Look, I have it closer to the line, but it's still not close enough. It should have been a lot closer right there. But it's pretty symmetrical up here at the height. So draw that bell curve. Now these lines, you don't have to put these lines there. I put those lines there just for visual, those vertical lines here. Like I usually will put a center line just so I can know that's the 50% point, 50 to the left, 50 to the right. Now your homework assignment says, now that you've drawn that and you put all the numbers there, if all the spaces under the bell curve to the number line equals 100%, that's one of the key numbers from the empirical rule. All of the area under the bell curve is 100%. From the mean in the center to the left is 50%. From the mean in the center to the right is 50%. Then here's your other three numbers. If we recall from the empirical rule, those other three numbers are saying that within one standard deviation of either side, that area underneath that bell curve is about 68.26% of the total bell curve, right within one standard deviation. Let me put this in terms, remember Tuesday I was talking about how we're a supplier for the auto industry, we're making these ball bearings, we're gonna supply for the auto industry, and an inspector came. Here's the deal, there's 10,000 ball bearings there. Odds are, in a normal sample, if I were to grab 30 of them, the mean of those 30, there's about a 68.26% chance it will be within one standard deviation if I had time to do all 10,000 of them. We don't have time to do all 10,000, so we have to rely on this empirical rule to say, if I pull out 30 and find the mean, then I find another random sample of 30 and find the mean. If I take all those means together, I should be able to estimate, because of the empirical rule, is going to have most of these means probably within one standard deviation of the real mean if I could do all 10,000. I'm not going to be able to do 10,000. By doing these samples, it gives me a good estimate as what the real mean might be. And I know statistically, as long as those samples that I did of 30, 30, and 30, maybe I did it 5 times or 10 times, the mean of those samples, as long as they're close to where I expect that mean to be, the agreed mean of each one of those ball bearings that between us and the supplier we agreed upon, as long as all those samples are within 1 or 2 standard deviations, then odds are all of them are going to be close to that mean we agreed upon. That's why sampling is done, because we know the probability. The empirical rule tells us the odds. Let's say if those samples are not within 2 standard deviations, that they end up being outside 2 standard deviations. First of all, I'd say, okay, what's the probability of that? What's the probability that our mean is outside of 2 standard deviations this way, or outside 2 standard deviations that way, going either direction? You can literally use the empirical rule to find that probability and find that probability and add it together. It's pretty small. It's real small, probably less than, I don't know, less than 6% probably, or somewhere around there. Meaning that if our samples are coming up out there, when we agreed with this supplier to have 4 millimeter diameter on these ball bearings, and our samples are out here, statistics is trying to tell us the probability of all 10,000s mean is probably not 4 millimeters. That it's probably too far above or below, and that's why our samples are showing up out in the tail instead of where they should be. That's how statistical process control takes place. Quality control is all about, hey, we don't have time to do 10,000, but if our random sampling takes place and it says, hey, no, it's showing up in the tails compared to where we think it should be, we're not accepting this order. You just made 10,000, you just wasted a ton of time, a ton of money making 10,000 ball bearings that we can't accept. So that's what this empirical rule is saying. It's saying, look, there's a 68% chance that our sample is going to be near that 4 millimeters. There's a 95.44% chance that our samples will be near 4 millimeters within 2 standard deviations as agreed upon. And so if all of our samples are within 2 standard deviations, then we have a 95.44% chance that if we had time to do all 10,000, it would be within 2 standard deviations. So we accept the order, and we're going to go ahead and write that check for $1.2 million for all 10,000 of those, because we need them in manufacturing, and these are meeting specs. That's how it works, you guys. The deal is on the first homework that you need to estimate what the shaded area would be from a certain point underneath this bell curve. And when I say estimate it, show your work, and there's like 10 different ways to solve it, and you must use these numbers from the empirical rule. 1, 2, 3, 4, 5, 150, 99.72, 95.44, and 68.26. Use algebra with those numbers to do that number line assignment, showing your work to tell me the percent of shaded area. Now let me give you a description so you understand what is being asked for here. If all the space under the bell curve to the number line represents 100%, 50% on each side, what would you estimate the percent of shaded space area would be at the point of 70.6 and to your left? So somewhere, when you make your bell curve, here it is. When you make your bell curve what was it again? 70.6? 70.6 is going to land somewhere, and I'm telling you for this first assignment, it's going to land somewhere on one of these dashes. Either at +1, +2, +3, -1, -2, -3. So it's going to be easy for you to estimate. Let's say it's from here over. You just got to figure out all of this and subtract it from 100. And the difference would be that little bit. Or you may say, okay, this part's 50, and this part is this much. From here over would be taking these two, subtract it from 50. There's 10 different ways to solve these. I don't expect you all to solve it the same way. I expect you all to use algebra on these numbers, but there's so many different approaches you can use these numbers in algebra to get to the right answer, but you will all get the same answer, whichever approach you take. So let's read it one more time so we're all on the same page. It says, estimate the percent of shaded space underneath the bell curve from 70.6 and to the left. You're going to draw your bell curve, you're putting the numbers in, all 6 numbers to the left and to the right underneath the +1, +2, -1, -2. You then are literally shading your curve. Shaded from 70.6 to the left. From the top of the bell curve all the way down to the number line should be shading, getting smaller and smaller as you get into the tail all the way to the end. That's the part you're estimating. Then show your algebra to tell what percent out of 100, how much out of that 100% is that shaded area represent using these numbers. Then, number 2. That's number 1. Everybody can form a picture how to solve that. Number 2, you don't need to draw another number line. You don't need to shade. Just visualize your current number line, but instead of from 70.6 to the left, this time pretend as if you're shading from 48.1 to the left. Wherever 48.1, I'm not expecting you to hand in a new shaded bell curve at all. I'm painting a picture for you so you can visualize it. The same curve you're using, but this time you're only shading from 48.1 to the left. Using these numbers again, and only these numbers, use algebra to figure out what percent that shaded area would be. Everybody get what's going on here? That's it, just 2 of them for the number line assignment. You just gotta do it twice. Once you're drawing it out and shading, and the other time you're just showing me the work to come up with that percent of shaded area. Is there any questions on that part of the homework at all? Everybody understand what's expected? It's too easy now, isn't it? Wait 5 days from now, we'll see how easy it is. All right. So that's it. Well then, I want to review something we talked about last week a little bit. I don't know what slide's on here. 25. Slide 25. Anyone following along? Range. I want to make sure you understand the difference between range and what is it? An interquartile range. Okay, range and interquartile range was last Tuesday. The interquartile range is where you went to the first quartile and you found the third quartile and you took those 2 numbers, whatever the results were, and subtracted them. And it's basically the inner 50% of the data. But range, I went over really quick because I thought it was really easy, but I want to make sure you get it. When calculating the range of data, you're using all the data. And you're finding the absolute largest number and the absolute smallest number and subtracting those 2. That's the range of the full data. So in this case, the largest number is 615, the smallest is 425, so the difference is 190, that's the full range. If I recall from Tuesday when we did interquartile range, it was only like 80 maybe. It was less than half that. So I want to make sure you understand the difference because on your homework, you got to find the range of some data. But you got to use Excel. So that's why you're being taught 2 new Excel functions. One is called max, one is called min. M-A-X, M-I-N. When you use max, and I'm using it right here, equals max, parentheses, what does that say? B8 dot dot B25 right there. So this column from B8 to B25, and let me look at all the data because I think there's some letters down here. Yeah, so it's even got some letters. So there's all the numbers and letters. It's looking at all of it, and it brings back the maximum number. It ignores the letters, brings back the maximum number. So if you look at all that data, the largest number is 232. So there's where max comes in. Everybody, you're gonna have to use max on the homework, so I'll make sure you got that. That's where max comes in. Next, min does exactly the opposite. Equals min, parentheses, B8 dot dot colon, B25, parentheses. Again, it ignores those letters at the bottom. It looks for the absolute smallest number, and it brings it back and puts it right there, which is 1. So now that you know how to find the max, you know how to find the minimum of a range of data, you combine the two to find the range using Excel. Equals max, B8 dot dot B25, minus min, parentheses, B8 colon B25, parentheses. That's using Excel to find the range. This is on your homework, I think. I'm pretty sure. You're gonna have to use Excel, maybe it's your quiz, I can't remember. You have to use Excel to find the range. This is the formula I'm expecting. You showing me you can use max and min. And I want to give you a hint. The data is so a small amount of data, you can look at it and tell me the range right off the top of your head. But the problem is about you showing me how that you know how to use Excel to solve it, using max and min to find the range. How do we feel? Can we all use max and min to find the range? We're good there? Okay. Here's another example, just to make sure. This time we're using column L. Let me see, is there letters in this one? No, there isn't. So column L, L8 to L25, the largest number is 876. Smallest number, the min, is 39. And the range is the max minus the min, 837. Now, your instincts will be, okay, take G, what is that? G14 minus G15. No, you got to pretend as if the max and min are not anywhere there. It's just asking for the range, so it's asking for one equation only, equals the max minus the min is the full equation then to find the range using Excel. I want to make sure you get this because we're about to learn, I don't know if it's next week or the week after, 2 more Excel equation functions called large and small. Very similar to max min, but large allows you to not just find the largest number, you can find the second largest, third largest, or fourth largest. Max only finds the absolute largest, doesn't allow you to find the second largest, just the largest. Small allows you to find the absolute smallest number, or the second smallest number, or the third smallest number. Min only finds the smallest number only. So, all right, that's max min. We're done with it. We know how to find the range using Excel. All right, good. Let's go to our written part of our homework. Here's the written part of our assignment. It says to manually show, to calculate the variance in the standard deviation, I thought. Hang on, yes, variance in standard deviation. It says 7 sample observations taken from a variable are as follow. The variables x, 12, 15, 14, 17, 14, 17, 16. Calculate the variance in standard deviation, showing your detailed work, calculating it manually, using the formula that you're about to learn. Let's learn that formula. Why not? Let's just go for it. Oh, we're not skipping anything. Man, where is it? Variances after interquartile range. Okay, right here. There's the formula. There's 2 of them there. For this class, we're going to be using samples almost the whole semester. So if you in the middle of a test going, oh, which one of these formulas should I use? Remember that odds are hugely in favor that you probably should use the sample formula, not the population, the sample. The only difference between these 2 formulas is what you divide by. In the sample, you're dividing by the number in the sample minus 1. So if I have 50 pieces of data, I'm dividing by 49, 50 minus 1 in this formula for the denominator. On the homework, boy, I'm giving it away. Darn it. Do I want to do this? Here we go. For the homework, if right away, your first thoughts are, if you're using that big old formula and you get to the step to where you got to divide, what do you think you're dividing by in this case? How many numbers are there? You tell me. It says there's 7 sample observations, but forget that part. What would you divide by? 6. You get it? 7 minus 1. I'm giving away your denominator already on this problem. Darn. It's that easy. But everybody looks at this formula though, and they go, oh my God, what is that symbol on the left? And what's the parentheses? And you got to square something. What's the I? What the heck's the I mean? Let me tell you, this formula, all it's trying to get you to do is you start in the parentheses and work your way out. And it's trying to get you to do it for each piece of data. That's what the I means. The I means do it for each piece of data, and then you've got to do this formula that many times. So on the homework, since there's 7 pieces of data, you'd have to do this 7 times. I forgot to open the example. But look at this example that I forgot to open. Hang on. Where is it? Variance example. Look at all this stuff. Where did all this junk come from? Here we go. There. Let's see, can I make it bigger? What I always do is I say, break this formula down to columns and do 1 column at a time. Start by putting in your data. Now in this case, how many pieces of data we have there? I can't tell because I can't see the denominator here, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. So what would we divide by for this problem? 11, very good, because this is sample data. And mention up here sample, it says sample mean, so it's mentioning somewhere in the story it says it's sample data. Just like on the quiz, it's going to say sample, this is sample data, just like in your homework. It says these are 7 sample numbers from sample data. There's all the data. The number 1 step in the formula is to find the mean of the data. So I'm going to do a shorter version here. Where's my pen? Some calculators whenever someone gives me a number off the calculator, I need someone to also tell me if they're correct. So I need at least 2 calculators working here. Here is only 4 pieces of data instead of 12. All right? The number 1 step is, notice in the second column, 35, 40, 35, 40, 35, 40, because that's the mean. You're subtracting the mean from each piece of data individually. So talk to me, what's the sum of all this? What does this add up to? I can't hear you, but I think it's 36.
Yes.
Okay, then we're dividing by how many numbers to find the mean? How many numbers do I divide by to find the mean? 4. Divide by 4 equals, here it is, 9, 9, 9, 9. Just like here, 35, 40, 35, 40, 35, 40. The formula says next, here's the formula, take each piece of data, x sub I, subtract x with a line over it means the mean. So we're subtracting the mean from each piece of data. So if you look up here, 3450 minus 3550, negative 90. 3550 minus 3540, 10. 3650 minus 3540, 110. Same thing here. 11 minus 9. 2 minus 9. Negative 7. 8 minus 9. Negative 1. 15 minus 9. 6. There it is. Now the formula says, take x minus the mean of x for each piece of data, now square it. That's the next step. So we got to take every one of these results, x minus the mean, let me make this a better x, there you go, and square it. That's all we're doing now is that part of the formula, square each number. 2 squared, 4. Negative 7, by the way, squaring it is all about getting rid of the negatives. So this column I'm doing right now should have no negatives left. Negative 7 squared, 49. Negative 1 squared, 1. 6 squared, 36. Okay, let me move this up a little so you can see the rest of the formula. The next step of the formula. So what we've done so far is we've taken each one of the data, x sub I, we subtracted the mean from each piece of data. We've done that step. We squared each piece of data. Now that symbol in front stands for sum of. S-U-M-O-F. Sum of. It means sum the whole thing. When you get all the way to the end and squared everything, add that up. So we're taking this last column. If you notice here, all of the squares, negative 90 squared, 8100, 10 squared, 100, 110 squared, 12,100. Then we add them all up, 301, 850. That's your numerator. So in this case, we have 50, 86. Wow, is that 90? 90 on the nose? 90 is our numerator. So I take 90 divided by n minus 1. In this case, there were 12 pieces of data, so n minus 1 said take that sum and divide it by 11. That's the variance. Let me repeat that. We did all these columns, we found the mean, subtract the mean from each one, square each one of those subtractions, add all those squares up, to then take that, all that addition, to divide it by however many pieces of data minus 1 to get to a variance. So what are we divided by here? 3. 90 divided by 3 equals 30. This is, come on, this is the variance. 30 is our variance. What does that mean? That 30 is our variance? It means the data vary from each other by about 30 units if it were squared. The amount the data varies from each other, the average amount squared is 30. So a lot of people go, the variance doesn't mean a lot to me because it's a number that's squared. It's so much larger than really what the data's. I mean, what's between 11 and 2 there? There's, what is that, 9? What's between 2 and 8? 6? What's between 15 and 2 even? That's 13? I mean, 30 doesn't make sense. The standard deviation is the true amount that the numbers deviate from each other. And to get to the standard deviation, you did all this work to get to a variance to then square root it. And you got the standard deviation. That's it. I'm now going to take the square root of 30 equals, and this is going to be the standard deviation. I now, whoops, deviation. Once I have that standard deviation, I can make a bell curve. The mean is 9. We calculated. The standard deviation is going to be whatever the square root of 30 is. Hang on, don't tell me. 5, 5 is 25, 6, 6 is 36, so it's between 5 and 6, so it's 5 point, what? Anybody? Right? Wait, come on. Nobody else. We're all relying on 5.47. We always go 4 digits.
Oh, 5.4772.
And what's the next digit to confirm your rounding?
2.
Very good. 5.772, going 4 digits to the right that we're doing in this class. That is the average amount these numbers deviate from each other. That's the standard amount of deviation. And if we were making a bell curve, think about it. Hang on, this is going to be awful. Hang on. Oh. What's the mean? 9. Here's 1, 2, 3. 1, 2, 3. 9 plus 5.4772 makes that 14.4772. Then we would add another 5.472. Subtract 5. We would then be able to do our bell curve, and we would know between 14.4772 and whatever 9 minus 5 point, whatever that is, 4 point blah 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 blah, 68.26% chance that if we were to draw one of these numbers out, it would be between those two numbers out of the sample or something like that. The point I'm trying to make is, you now know how to find the standard deviation. You now know that the standard deviation represents how the average amount the data spreads from each other, is apart from each other. And now you are putting it together as to how that bell curve's done and how this empirical rule relates to sample data. Can you guys now do, hang on, I didn't see your hand, hang on. The homework, do you see what's needed to be done to find the variance of this data and then that last step to get to the standard deviation? Everybody see it? You can do it? There's only one of them there. I took one away. I think he had a question. I'll come to you.
When you added all of that, did you divide it by 4 or by 3?
I divided by 4 because there was 4 pieces of data.
Well, aren't you supposed to do minus 1?
No, only when you get to the end. To do the variance calculations, n minus 1. This is just finding the mean. So that's why I divided by 4. I had to find the mean. So I had to add up all the sample, divide by 4 to get to the mean. But when I got here, this 90 has to be divided by only 3 because that's the variance calculation at the end. Oh, wait, she had a question, and I'll go you.
Oh, I was just gonna ask if you guys put the bell curve into the homework.
Is it okay to put a bell curve in the homework?
No, do we have to?
No, you don't have to on this part of the homework, but on the number line, you gotta give me a bell curve. Shade it in, remember. Okay, wait, him and then you go ahead, Ali.
It says sample, so we use a sample, but like if it says population, well, it's
The odds of it saying population on a quiz or a homework, or even a homework or the final exam are almost 0. I don't wanna trick anybody. I want you guys to focus on the sample formulas, because in 302, you're using all samples.
Okay, but will it like, it'll say population in one system?
If I were trying to trick you, I would definitely put the word population there to try to not trick you so much. But I'm not gonna put population. You can count on me using sample, okay?
Do you put the repeated number or no?
Do I put a repeated number?
Like, see on the homework, it's under X, you put the repeated number or no?
On a quiz, you mean like?
No, like on the homework.
On the homework, there is a repeated number. I'm sorry, this fan is keeping me from hearing
You
you.
add the added number under the column,
Added number to the column, what do you mean?
figure this out.
Saying, do you add the repeated number in the column because it's repeated?
Yeah, you treat it just like a separate piece of data, ignore that it's repeating. Yeah, I think, I'm sorry, I misunderstood your question, but yeah. So once you find the mean, you're subtracting it from 17 twice, and you're squaring that subtraction 2 different times, and you're adding that into the numerator twice, because 17 got repeated, yeah. Go ahead. Hang on, I gotta turn this on. I can't hear you guys. Give me a little volume, go.
So when showing our work, do you want us to use like a table, how you did, or do you want us to individually plug in each one?
It's up to you, but you gotta show me how you got to this answer, whatever way you decide to do it. If you, like, I think on the answer on the homework, when I get it posted next Tuesday, I don't think I set up a table like this. I think I did it straight across, 11 minus 9, 2 minus 9 equals, I think because of the way I was typing it, I couldn't form the columns, I was in a hurry. So you can do it any way you want, as long as you're showing me the detailed calculations. You don't necessarily have to do the columns. I'm telling you, that's the easiest way though. That's the easiest way to do the columns. And I wish I could have typed it up that way when I was doing the answer. Maybe someone can make a new answer for me after the answer's posted. How do we feel? Can we do the written part of this week's homework? You gotta do the variance and the standard deviation for just one set of numbers. In the old days, there were 2 sets. You had to do it twice. If you really wanted it to soak in, but you only have to do it once. Now, let's look at, wait a minute. Let's look at, here. This is, go ahead.
When we find the standard deviation, how many numbers do we write?
4 digits to the right. Like she said 5.48, and I said, is that 4 digits? She corrected to 4.772. The next digit was a 2, that's why we kept it at 2 at the end. For the whole semester, just let it be, always go with 4 digits to the right of the decimal the whole semester. I think a couple of you lost like 1 or 2 points for only going 2 digits to the right on the homework or the class, I can't remember.
So in the equation, S2 stands for variance?
S with a little square up there stands for variance, because this is what gets square rooted. If you square root that, then it equals just 1S, which is your standard deviation. Now, there's other books that will use this symbol instead. Looks like that squared. Then if you square root it, it equals that. It's like a little omega symbol, or whatever that's called, alpha. I don't know what that's called, but our book's using an S. So don't let the symbols, changes in symbol fool you. It's just the variance, the standard deviations are always the square root of the variance. Square root the variance to get the standard deviation. Standard deviation, a couple people on a quiz last semester squared the variance instead of square rooting it. Remember, the standard deviation is always a smaller number than the variance, because you're square rooting it. Where did we leave off?
Number line.
Excel variance, thank you. Here we go. Here it is. Here's the mean. We know to use AVERAGE, average. Variance, VAR. There is the function for variance. When you want to find it, look at the data above here. From cell, what is that, C11 through C15, VAR will find the variance. The variance of this data up here is 68. Standard deviation, STDEV. Where are we? STDEV. I put an extra D there. VAR, we did min, we did max, range, empirical rule, variance manually, standard deviation manually. You now can do the variance and standard deviation using Excel. Let's look at it again. VAR E11.E15, the variance of these, how many pieces of data we got? 1, 2, 3, 4, 5 pieces of data is 21.5. The standard deviation, STDEV, E11, E15 is 4.6368. And look at the range, equals max E11 through E15 minus min E11 through E15. We could easily see the biggest number is 17, the smallest number is 6. But this is all about showing me that you can use Excel to find the range, max and min. This class is almost too easy. I can't believe you guys aren't bored.
What was the standard deviation? STEV?
ST, what? Hang on, I gotta remember. STDEV. STDEV. All right,
Can we use that function to check if we got the homework?
absolutely.
The range is max equals.
Oh, absolutely. I don't want to give it away, but you're gonna be checking your manual homework by doing the Excel assignment. You still, even though I just gave away a big hint there, you still gotta show your work when you do this manually, step by step, how you guys got your variance and your standard deviation manually, okay?
What do you mean, man?
Manually on that first homework assignment, the written one, you gotta manually calculate your variance and standard deviation. When you get to the Excel one, yes, I happen to have set it up, one of the, part of the Excel part happens to have the same numbers.
Yeah, X.
Now you see it? Whoops, hang on, where's the Excel assignment? There's the Excel assignment. You gotta do the variance for X there, standard deviation for X there, do the range for X there. You're using this spreadsheet, so we all get the same answers, and you're writing down whatever you enter into Excel there and the results from those yellow boxes onto a piece of paper when you hand this in on Tuesday. You're not handing in the spreadsheet, you're using it. You're gonna have, just like when you're working on your test, you're gonna have Excel open in front of you while you're taking the test, and you're using it to enter the equation, but you're writing the equation down the test, and you're getting the result off the spreadsheet to write onto your test. So you got 6 answers to write out for the Excel part. Does everybody feel comfortable they know what to do for the Excel portion of this week's homework? Everybody, okay? You just got 6 of them there, 2 variances, 2 standard deviations, and 2 ranges. Now, this is not on your homework. The last big thing, before we do the in-class, how are we doing on time? We're doing okay. Before we do the in-class, this is called correlation. Equals C-O-R-R-E-L, parenthesis, you give the location of one set of data to compare it to another set of data. So as you look, it says C11 ... C15, comma, then it says E11 E15. It's telling the computer, hey, look at the data between C11 C15, compare it to E11 E15, and tell me if a correlation exists. Now let me make sure you understand what correlation. Meaning there's some kind of mathematical resemblance between these 2 sets of data in the order in which they're being presented. Let's look at the X. It goes from 6, then it goes to 11. Look at Y. It goes from 6 to 9. They both went up in value. Then X goes from 11 to 15, but Y goes from 9 to 6. One goes up, the other one goes down. So they may not be totally correlated. So let me make sure you understand. Correlation is always between +1 and -1 as a decimal. 0.55, 0.27, -0.62. It's being presented as a decimal. It's almost never exactly 1.0 or -1.0. It's always in between. The closer the correlation number is to 0, the weaker the correlation between the 2 sets of data, that they're not really resembling each other or going the same direction or don't even make sense. The closer the correlation is to -1 or +1, the stronger the correlation. So I'm going to set some little boundaries here. Hang on a minute. -0.3, -0.7, +0.3, +0.7. Approximately those numbers. And I'm telling you, there's a question about correlation on either one of your tests or your final exam. So I'm gonna make sure you get this. The question is gonna be, the data has this particular correlation, -point something something. You need to turn it into words, and there's 6 words. You ready? There's strong negative correlation because it was up above -0.7 and really close to -1. Like an example would be -0.88. That's strong negative correlation. There's average negative correlation. It's between -0.3 and -0.7, somewhere in there. And then it has average correlation. Between -0.3 and 0, that's called weak negative correlation. So let me review those 3. Strong negative, average negative, weak negative. The same thing's on the positive. Weak positive, average positive, and really close to +1 would be strong positive correlation. Go ahead, Alan.
For the standard deviation one, there's standard P and S. Which one do we select? Isn't the S on the Excel?
What are you talking about?
Like when you write in the formula, there's STDEV dot S and S.
Oh, just use, don't even use dot anything, leave the dot off, see if it works. Just use STDEV only. All right, you ready? So, here's what it means. If we end up with a really strong positive correlation, it's like between +0.7 and 1, somewhere up there, it means our two sets of number seem to be going the same direction. As one goes up, the other one's going up, or as one goes down, the other one's going down. And they seem to be going up in a similar fashion in the same direction, whether it be up or down. That is a strong positive correlation. Now, a strong negative correlation means they're also correlated, but they're going in opposite directions. As one set of data is going up, 6, 11, 15, maybe the other set of data is going down, 6, 4, 3. As one goes up, the other one's going down, but every time one goes up, the other one's going down of maybe an equal amount, they'll have a very strong negative correlation. So both scenarios are very correlated. If you can get a weak positive or negative, it means there's nothing going on. One's going up, the other one may be going up. The next minute, the other one's going up, but the other one's going down. That they're not really correlated together at all. They're just doing their own thing. That would be really close to 0. When you get the number, you got to include whether it's weak, average, or strong, and you've got to include whether it's negative or positive. Those are the words you got to use. Let me repeat that. Include the words negative or positive, and whether it's weak, average, or strong in your answer. You ready? I heard some of that question, but here we go. 0.87. Describe that correlation. A negative 0.87 is, how would you describe that correlation?
Strong negative.
Strong negative, very good. That's exactly what it is. 0.21, they describe that correlation. I heard it somewhere back here. Weak positive, there you go. This is almost too easy, isn't it?
Yeah.
What kind of correlation do these two data have? How would you describe that correlation between those two data? Hang on, let me put it on the correlation. Hang on, let me get my pointer here. There we go. How would you describe that correlation? This is darn close to a controversial which one it's going to be, but without rounding, how would you describe that? Average positive. Darn close to being what though?
Strong.
Strong positive. One more tenth, and we could really call it strong positive. When I give this on a test, it will be obvious which one it is. It won't be close. It won't be between two of them, okay? It will be obvious. It'll be one answer, and it'll be clear what that answer should be. Either average positive, or weak positive, or strong negative, something like that. Average just means it's mediocre. It's like, yes, there's a correlation, but it's not that strong and it's not weak, but there's a definite correlation between them. Either they're going in different directions or they're going the same direction. Right? Everybody get that? Again, positive correlation means the datas are going in the same direction. Either they're both going up or both going down. And a negative correlation means the data is going in opposite directions. This data is a positive, so it means they're kind of going in the same direction, which they are. Notice from top to bottom, X is getting larger, and Y is getting larger, even though it gets larger than smaller, but then it gets larger, smaller. But in the big picture, they're both getting larger. The correlation is not strong, but there's a definite correlation there because they are both getting stronger, and it is a positive 0.69. So it's kind of an average correlation. All right, let me keep looking. Oh, has anyone noticed yet that when you go on a PowerPoint on Canvas that sometimes the equations are not showing up, or you probably don't even realize the equation's missing? For some reason, on Canvas, to make the PowerPoints work for you for the quiz, download them, then open them up. Don't open them up in Canvas. You're missing some formulas if you open them up in Canvas. Some formulas are not appearing for some reason. If you download it first, then open it up in Windows or whatever, it will always show the formulas. So please do that for the quiz. Get everything on that flash drive. Don't open it up in Canvas and then turn off the computer while it's in Canvas. Download it and so you get all the formulas. That's all I got. You ready for the in-class assignment? I'll pass back the rest of these while you're taking the in-class. Don't forget, spend some time working on the in-class on your own.